Well, greetings all. Here's what you missed the other day on Monday, 4/28. What I did is I fielded any questions that they might have had before the quiz. On your quiz, there happens to be 4 antiderivatives where I give you the numbers. That way you can check them on your calculator. There's one question for Riemann sums where I talk about left bound, right bound, and the midpoint method for estimating the area under a curve, which ties into what we do today. And there's 2 area under the curve. So that's what your quiz wound up being over. But I do need to cover with you volumes today. On your class examples, I am not going to go through where it says average values. And then these are not on your class notes, but here's where I got to take you today. This happens to be a figure that we found the area of the other day. This happened to be the graph of the square root of x, and this happened to be the parabola, y equals x squared. And they happen to intersect at the point 1, 1. But last time we just found the area of this. What I'm going to do with it today is spin it about the x-axis so that it creates this kind of a figure. That's where I got to take you today, is I got to teach you how to find the volume of something that looks like that. I've got a couple of slides. I'm hoping to explain a little bit to you what happens, and then we'll go from there. Here's where it all comes about. This happens to be the graph of y equals x squared on all 3 of these graphs. Here's what I did. I went into my Riemann sums calculator and I said, hey, draw me 4 left-bound rectangles. Here's where I got to go today. We're going to picture this. We're going to revolve this about the x-axis. So think about what I'm going to have. I'm going to start spinning this rectangle about the x-axis. Well, once I do that, I'm going to get a cylinder. In this case, I'm going to get a cylinder that's going to be 1 inch in width. Because it looks like I went 0 to, well, it looks like I went 0 to 2. So this would be a 1/2 inch in width. I'm also going to get another cylinder here, another cylinder there, and a little bit there that we're not going to worry about for now. But if you notice, that's not very accurate. There's a lot of wasted space in here. So what I did is I told my calculator, come back in and put 8 rectangles in here. So that now when I revolved this thing, and it's hard to see, I'm going to start spinning this rectangle about the x-axis. So once I do that again, I'm going to get 1, 2, 3, 4, 5, 6, 7. I'm going to get 8 cylinders. Well, to estimate the volume that this curve would generate, I'm going to have to add up each of those volumes of the cylinders. Still not good because I got a ton of waste in here again. So what do? I tell it to put more rectangles in there. And then once I revolve this about the x-axis, I'm going to get some more cylinders, but I'm going to have less and less waste. My goal today is help you see, be able to find mathematically. I think it's pretty easy. But I have to have you be able to see what you're going to be finding once we start spinning this about the x-axis. Also think about this. Remember, since each of these are a cylinder, to find the volume of a cylinder, it's going to be pi r squared. That's going to take care of the circular part times how tall it is. For our purposes today, I plan on having so many rectangles in here that we don't even have to worry about the h. So come over to your first, like I said, I'm going to skip these. But here's your first example. I'm going to do it calculus style and then non-calculus style. Calculus style says this. Well, let me do non-calculus style first. I just changed my mind. Pretend for a second. Here's the graph of 4 minus x squared. Cuts in at -2 and 2. What I'm going to ask you to do is shade this in. And then I'm hoping you could visualize the figure that you would get once I start spinning this about the x-axis. If I start spinning this about the x-axis, I'm going to get something that looks like a baseball or a softball, volleyball, something like that. So once I start spinning that about the x-axis, I'm going to get a sphere. Well, a sphere, that's the easy part. The volume of the sphere is 4/3 pi r cubed. So I'm going to get 4/3 pi. In this case, my radius happens to be 2, so 2 cubed. So it looks like the volume of this is 32/3 pi. Technically units cubed. I'm not going to get caught up in that units cubed. What's hard to see though, guys, on this, again, is within this easy problem is I have all this area, and I'm going to make little rectangles in here, left bound or right bound, that doesn't matter. And I'm going to rotate those about the x-axis so I have a bunch of cylinders in here. There's what the problem looks like here. Think about this. As I revolve this about the x-axis, I'm going to get a bunch of cylinders, and I'm going to get something circular in here. Well, the area of a circle is pi r squared. That's going to be key in what we do today when we find the volumes. I got another easy one, then I'm going to come back to this same problem and show you what it looks like calculus style. Here's this same problem. Sketch the graph of y equal 1/2 x on 0 to 4. What figure could be obtained about rotating it about the x-axis? Find its volume. Well, here's what we got. I'm going to go from x equals 0 to x equals 4, so I'm going to get this figure right here. This figure is a little easier to see. When I start rotating this about the x-axis, I'm going to start spinning it really, really fast. I'm hoping that you notice that that's going to be a cone. So the volume of this cone is going to be 1/3 pi r squared h. So it looks like 1/3 pi. It looks like my radius up here is 2, so 2 squared is 4. And it looks like my height of this thing is also 4. So the volume of this thing is 16/3 pi. Technically units cubed. Like I said, I'm going to come by and get that here in again a little bit. But picture, if you can, a rectangle drawn right in here. And I'm going to rotate that about the x-axis. So I got a cylinder, a cylinder, a cylinder, a cylinder. The more cylinders I can cram in there, the better off I'm going to be. And there's some information about it, but I'm going to keep getting to that. To find the volume of anything calculus style, here's the formula. The volume of any figure that we want to talk about can be found by pi times the antiderivative from a to b of f of x squared. Really, guys, here's what we're doing. If I'm taking that figure again, as I spin this part around, I'm going to get a circle. Well, the area of a circle is pi r squared. Check your formula out. Pi, f of x is really your r. I have a radius here. I have another radius here. I have another radius there, 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 ever how many I want to put in there. So to find the volume, there's my formula. Volume is pi times antiderivative from a to b of r squared, which we're going to call f of x squared. So here goes that same problem that we started the class off with. This time I'm going to do it calculus style. To find the volume of this, it's going to be pi times the antiderivative of, I'm going to go from -2 to 2, of the square root of 4 minus x squared squared, dx. Well, let me simplify this then. I'm going to have pi times the antiderivative from -2 to 2 of 4 minus x squared. Square root and squared cancel each other out. Let me find this antiderivative then. So I've got pi times. When I write this, I usually go pi, and then I just do a bracket. The antiderivative of 4 is 4x minus 1/3 x cubed. I'm going to put my other bracket or my line, and I'm going to evaluate this from -2 to 2. And since this is a video and I'm trying to save time on it, when I ran 2 through here, and then subtracted it from what I got when I ran -2 through there, I had 32/3 times this pi. So my volume is 32/3 pi. And if you look back at your first example, that's the exact same thing that we got. Here's that second one. We want to find this volume. So my volume is pi times the antiderivative of 0 to 4 of f of x squared. So this really becomes pi times the antiderivative from 0 to 4 of 1/4 x squared dx. Let me go ahead and take care of the antiderivative then. So I got pi times the antiderivative of 1/4 x squared looks like 1/12 x cubed, and I'm going to evaluate that from 0 to 4. Well, let me run 4 through there. So I'm going to get 64/12 minus 0. And looks like 4 goes into both of them. So my answer, 16/3 times that pi. What's hard to realize is within this equation, you're really finding the area of a circle. The 0 to 4 takes care of as many rectangles as you can cram in there. Okay. This one's not on yours, but here's the graph of y equals x squared from 0 to 2, and then I spun it around the x-axis just so you could kind of see the figure that it would make. And then I forgot how many rectangles I put in there. You can kind of tell from each of the lines, but this would be an easy thing to find the volume of now. It would just look like this. The volume is going to be pi times the antiderivative from 0 to 2 of x squared squared. So x to the 4th dx. So this really becomes pi times 1/5 x to the 5th, evaluated from 0 to 2. Run 2 through there, looks like I'm going to get 32/5 minus 0, all of that times pi. So the volume of this thing, 32/5 pi. So that's the majority of the lesson. Of course, I've got some harder ones coming up that I'll just throw the numbers out at you and show you the setup. But here's just kind of another one. Here's the graph of y equals square root of x. Then I went ahead and revolved it around the x-axis, so we get a figure that looks like that. This one is your number 3. Your graph and my graphs are going to look different. Because what I did is I took my calculator and I spread it out so you could see it better. So really, here's what your graph would look like. You have y equals x squared, and we're going to go from 1 to 3. So here's the area that I'm spinning about the x-axis. Oh, kind of hard to figure out what that might be. Might be some weird shaped bowl that you might throw fruit in that you set on your table. But the math part of it's real easy. Here comes the math part of it. The volume of this thing as it's spun about the x-axis is pi times the antiderivative of, I'm going from 1 to 3, of f of x squared, so once again, x to the 4th. Technically, there's a dx. Then this becomes pi times 1/5 x to the 5th, evaluated from 1 to 3. So it looks like this now becomes pi times 3 to the 5th, sounds like 243. So I got 243/5 minus, let me run 1 through there, 1/5. So the volume that this figure would make, 242/5 pi. Okay. I got my hardest one coming up on my 4th one. I'll show you the setup of it, and then we'll talk numbers. But here comes this next one. I'm going to find the volume of this figure. And I'm going to go from negative 5.5 to 5.5. So we're going to spin this part here in black about the x-axis. So that's the figure. Think about that for just a second. See if you can figure out what figure that you're going to be finding the volume of. The official name of it is a prolate spheroid. Prolate spheroid. And I'm going to bet that 99% of you have thrown one of these. In layman's terms, we call it a football. So we're going to find the volume of this football. This is a regulation size football. So let me get rid of the name of it, and let me show you the setup. The setup's going to look like this then. The volume of this football is going to be pi times the antiderivative of negative 5.5 to 5.5 of negative 0.1 x squared plus 3.4 quantity squared. So of course, what am I going to have to do with this? I'm going to have to FOIL this thing out, find the antiderivative of it, and run it through my calculator. You also, if you see little things like this, you're welcome to use them. I won't on this example. But I could, if I didn't want to go from negative 5.5 to 5.5, if I saw symmetry right here, I could go from 0 to 5.5. I would just have to remember to double my answer. I won't do that, but you can do that if you like. So here goes. The volume of this thing is going to be pi times the antiderivative from negative 5.5 to 5.5. When I ran that through and FOILed it out, I had 0.01 x to the fourth minus 0.68 x squared plus 11.56. And then when I found the antiderivative of it, added 1, multiplied by 1/5, I had 0.002 x to the fifth minus 17/75 x cubed plus 11.56 x. And I'm going to evaluate that from negative 5.5 to 5.5. Hey, I have all the faith in the world in you that you could run that number through minus that number through. When I did that earlier, I had pi times 35.93 minus negative 35.93 approximately. So my approximate area of this football, 71.87 pi, which is approximately 225.78 cubic inches. I snuck in the cubic inches because I knew I was talking about a football. Okay. My next one's kind of a little hard one to see also. We'll see what we think here. Picture this if you would. Here's the graph of 25 minus x squared. Once again, it's a semicircle. I'm going to start spinning this semicircle around the x-axis again. So what I'm going to do is I'm going to get a ball again. A softball, a baseball, a shot put, something like that. Volleyball. I don't want to use volleyball because it could go flat with what I'm going to do next. But what I'm going to do next, guys, is I'm going to shoot a knife through here, a sharp laser beam kind of things. And what it's going to do, it's going to cut a hole in the middle here. So I'm going to end up with something like an olive. So I'm going to have something circular that has the center cut out of it. So that's what I'm going to be finding now. So I'm going to find the volume of this piece right here spun about the x-axis. Okay? And this method is called the Warscher method. It becomes the Warscher method if you're going to cut something out. So here's how this setup's going to work. I need to first figure out the points of intersection of my two graphs, of the line y equal 3 and the 25 minus x squared. And when I did that, it looks like they're going to intersect at 4 and negative 4. So here's how this problem is going to set up. To find the volume of that thing, it's going to be pi times the antiderivative from negative 4 to 4 of your upper bound squared minus your lower bound squared. So it's going to look like this. My upper bound squared is going to be that 25 minus x squared square rooted. Well, once I square that, I get 25 minus x squared minus my lower bound squared, 9. So here's what I got now. I've got pi times the antiderivative of negative 4 to 4 of negative x squared plus 16. Now I'm off to the races. I'm going to find this antiderivative, negative 1/3 x cubed plus 16x, and I'm going to evaluate it from negative 4 to 4. Once again, if you saw symmetry, you could go 0 to 4. You just have to remember to double it out there. Since you're not in class and I can't re-explain that, I won't mess with that. So this becomes pi times, and when I ran 4 through here minus this, I wound up getting 256 thirds. So the volume of that thing, volume would be 256 thirds pi. Okay, and that's called the Warscher method. You'll recognize the Warscher method because there's two graphs to work with. You're not bounded by the x-axis, and there's going to be a hole cut in there. And really, I've only been on the video 20 minutes. I've only got one more example, so hopefully I haven't gone too fast. It's one of those lessons that sometimes it just doesn't flow like I would hope it would. But here's the Warscher method that we just used. It's pi times whatever your bounds are of your upper bound minus your lower bound squared. But here's the last one. Here's the figure that we're going to get. Oh, looks like I just threw that one in to show you what it would look like. We're not going to do this one, by the way. This happens to be the graph of e to the x minus 1 and the line y equal 3/2 x. So I got that figure. Spun about the x-axis, we wind up with something cool looking like that. Here's a picture of the one you're going to be doing next. It's kind of the one I started class off with. Here's the graph of, let me get white ink here. Here's the graph of the square root of x. Here's the graph of y equal x squared. And really, on a grid, it's way down here. I just blew this up. And they're going to intersect at 1, 1, the point 1, 1. When I spin it about the x-axis, looks like we're going to get this figure from outer space. Mathematically, it's not going to be bad. So here goes your last one. To find the volume of that thing, because here's the area that I'm spinning about the x-axis. Well, to find that volume, it's going to look like this. Volume's going to be pi times the antiderivative of. I'm going to go from 0 to 1 because I'm starting right there, and they intersected at 1, 1. Of the upper bound squared minus the lower bound squared. So it's going to look like this, pi times 0 to 1. My upper bound, when I color, looks like the square root graph. So the square root graph squared becomes x minus. My lower bound is the parabola, y equal x squared, squared. So x to the 4th. So there's what I got so far. This now becomes pi times 1/2 x squared minus 1/5 x to the 5th, evaluated from 0 to 1. If I run 1 through here, it looks like I'm going to get 1/2 minus 1/5 minus, and when I run 0 through there, I'm going to get 0. So it looks like 5/10 minus 2/10. So this volume looks like 3/10 pi. So that's what we got going on today. My next to the last unit that I get to cover with you. The assignment was listed on there. It's also listed here, but it's listed on your class example sheet as long as you have that. And then I added in this example because our book did a terrible, terrible job of the Warscher method, and MathXL wasn't any better. So if you would, add that one in, and good luck. Come in if you need any help. Make sure you get your quiz made up. Take care.